Java statements are executed top to bottom unless this flow is altered by the evaluation of Boolean expressions. Booleans were briefly mentioned while discussing data types, and to quickly review, variables of the Boolean data type can only store a value of true or false. In this video, we will look at one of the three different types of operators used in Java to evaluate Boolean expressions. There are four relational operators in the Java programming language. They are less than, greater than, less than or equal to, and greater than or equal to. All relational operators compare two operands accordingly and return a value of true or false based on the evaluation. For example, using a printline statement, let's see what is returned when we use the less than relational operator in comparing 2 and 3. You can see true is printed to the console as 2 is less than 3. And if we switch the numbers around and place 3 on the left and 2 on the right, our expression being evaluated is no longer true, as 3 is not less than 2, it is greater than 2. So we see false is printed to the console. We can change the operator to the greater than operator, and now the expression will evaluate to true. If we change both operands to the same number, what do you think will be printed to the console? We will get false because 3 is not less than or greater than 3. The operands are equal. So if we wanted this Boolean expression to evaluate to true, we could change the operator to the equal operator, or we could change the operator to the less than or equal to or greater than or equal to operators. For now, let's change it to the less than or equal to operator. You can see we get true printed to the console. Likewise, we can change the operator to the greater than or equal to operator and still get true printed to the console. The purpose of each individual Boolean expression in your code will ultimately decide which operator is needed. Deciding which relational operator to implement should take thought, as there is a right and wrong operator to use, and using the wrong operator will likely cause your program to behave undesirably. Before we end this video, let's look at one more example using chars. Notice I have replaced the integer operands with char operands. We know this to be chars and not strings because they are enclosed in single quotes and not double quotes. So here we are comparing the characters b and a. In more detail, we are evaluating if b is less than a. What do you think will be printed to the console here? Notice we get false, but why? It is because we are actually comparing the ASCII values of these characters. Wikipedia tells us ASCII codes represent text in computers, telecommunications equipment, and other devices. In other words, the characters and symbols on your keyboard have numeric values connected to them which allow computers of different makes and models to interpret which characters are being communicated. If we look at this list of characters and their corresponding ASCII values, we can see that the corresponding value for A is 97 and B is 98. We can actually prove this quickly by storing a char in an int variable, which works because it is the integer ASCII value being stored in the variable. And if we print out these variables, we can see we do get the same values on the list we just saw. So when we have a Boolean expression with relational operators comparing chars, the operand is actually comparing values, in this case 97 and 98. In the next video, we will look at logical operators.